Hello everybody, this is Professor Jason Kim. Today's video is about the probability. In this chapter consists with the in chapter 5 in probability. It consists of two major parts. One is a 5.1, which is a single event probability. And the other one is something called chapter 2 and chapter 5.2 and 5.3 is about the multiple event we call compound event. Probability. Single event is easy. That's when one event occurs, how they find the probabilities. Now, many of my students are having a hard time on multiple events. When you have a multiple events, which means more than one event happening sequentially, then sometimes we multiply them. So we use the multiplication rule, and sometimes we have to add them, so we use addition rule. And the keywords that it apply the multiplication rule is something called A and D, and the keywords that indicate the addition rule is OR. So we're gonna talk about the like this kind of setup. Okay, so this single event one, first we have to know what is the probability. Actually probability is not a actual value things. The probability is that likelihood that event will happen, occur. It measured by ratio, so like a fraction of the favorable case to whole number of case possible. So it's like ratio means like A over B. So it's like how much it will happen, how much favorably happen out of the whole case. That's what probability is. So ratio of that is probability. So many times probability expressed in fractional format, like A over B, or decimal format, like 0.234. So there are two ways of express a fractions. And the way you express the fraction is like P of A, and P of A, it reads as P of A, and it denotes probability of event A. That's what we call P of A. So P means probability and A means event A. So if it's event B, it will be P of B. And if it's event C, then it will be probably, we try to look for probability of C. But let's mainly talk about event A, since it's a single event. If the probability of P of A is 1, the event is always happening. And you have to also know that when probability of 0, that event A would not happen at all. Okay, so that's what indication that we have. 1 has always happened and 0 is never happened. So probability of A is always between less than equal to 1, which means always happen, and bigger than equal to a 0. That means it's sometimes it never happen, Okay. So again, what is probability of events? The probability of events is number of outcomes favorable to happen out of total number of outcome. So that's how you express in ratio format or fractional format. So probability is based on equality-like outcomes. So let's look at the example. In example 1, let's see that a box contains 3 green balls and 2 red balls and 4 blue balls. And a ball is randomly selected. It has to be random. That means you don't see inside. You don't know what you are picking when you pick a ball. And if color is noted, then it is placed back into the same box for after you finish it. So if that's the case, find the probability of a one selected ball or a selected ball is green for number 1 and blue for number 2 and red for number 3. So how do you find a probability of when you pick a ball and it happen to be a green ball? So that means in ratio, number of green out of total number of balls. That's a probabilities of when you pick up one random ball, it happened to be a green ball. Because out of the total number of ball, number of green that you have is the possibilities favorable because that's green and you're looking for the possibility of picking up a green ball. So first thing you do is you always have to find the total of it. So total number of ball is 3 green, 2 red, and 4 blue. So altogether become 9 balls. Okay. So probability of green, so in short we say probability of G would be there are 3 green balls out of total of 9. And then you reduce them, it becomes 1/3 is your final answer. But in our purpose, we're going to just stop at the 3 out of 9, just to indicate that there are 3 green balls and 9 total balls. So solution in here, probability of green would be 3 green balls out of 9 total balls. Likewise, then what would be a probability of choose a blue ball when you randomly choose one ball out of from this box? So since there are 4 blue balls, it will be 4 blue ball out of 9 balls, so end up with 4 over 9. Does everybody understand that? Okay. Now, what would be when you choose one ball randomly, what would be the probability of that ball would be a red? Then it would be total of 2 red ball out of total of 9 ball. So and your probability of picking up that ball is 2 out of 9. So does that make sense? Good. So let's look at another example. Now let's say there is a local company has following company cars. So company number A has 60 cars, company number B has 70 cars, and company number C has 80 cars, and company number D has 40 cars. So which means that the total number of cars would be adding all this number. So that would be 60 plus 70 plus 80 plus 40 would be 250. So total number would be 250. Then what would be when you randomly choose a one car, then what will be the probability that belongs to company A for number one, and number two for company B, and C and D for rest of the other question? Then the probability of that you will choose one car that happens to belongs to company A would be total number of company car in company A, which is 60, out of total number of cars there, 250. Okay, so that would be a probability of choosing a car from company A. That makes sense, right? Yeah. So then how about probability that you choose a car that belongs to company B? Then it would be there are 70 company B cars, so 70 out of a total number 250. It's not that bad, right? So how about probability of when you choose one car from like multiple parking lot, and the one car they randomly choose belongs to company C, would be 80 company car from company C out of 250, as well as 40 company car out of 250 when you look for probability of a car that happen to be belongs to company D. So that's how you do it. So it's single event probability is not that bad. Just have to make sure you get total number of event and then individual number for each cases. Okay? Now there is another thing that you should know is something called law of large number. When you do it many times, so long run, the sample size increases. As the sample size increases, the relative frequency of the outcome get closer and closer to theoretical probability value. Okay, so what they're saying is if you have a large number of sample, then the probability get as close as the theoretical or actual probability value. So which means, in other words, what they're saying is when you have a larger number of data, it's more accurate. That's what I'm saying. That's what they are saying here as well. So more sample you have, your accuracy goes up. That's what law of large number. Okay. And sum of all the probability has to become 1. That's what they're trying to portray to you. And let's say there are 3 probability, then let's say probability of 1. So n was 3, right? Probability of 1 and probability of 2 and probability of 3. So sum of all the probability always equal to 1. That's the maximum number you can have as a sum of all the probability of that event, of the same event. Okay. And next concept is complement of a event. So let's say there is a probability of event A complement we call probability of event. And you write small c there if you want to say as a complement. And when you add this two probability of event A and complementary event A, always end up with 1. Okay? So from there, you can even write that probability of complements is always 1 minus probability of regular events. Okay? So what, in other words, if probability that it'll happen is 0.7, you can find probability it will not happen as 1 minus 0.7, which is 0.3. Okay, then that becomes 0.3. So you can find a complement of a probability when you know a one probability of one event. Okay, and sometimes we use complementary events for various reasons. So I'm going to explain that further later on, but you should know this. The example is if the probability of A is 0.2, probability of not A would be 1 minus 0.2, which is 0.8. So that's how you find out the complementary value or complementary probability value. Again, if probability that it will happen in event A is 0.75, then that probability that will not happen would be 0.25 because it's 1 minus 0.75. Sometimes we express the probability as a percent. So let's say the probability it will happen is 20%, then probability it will not happen is 80% because total is always 100%. Okay. But I have to point it out that probability expressed in percent is not a calculatable value. So the best way to do addition, subtraction, multiplication, division of percent involved with the percent thing is you change the percent into the decimal. So 100% is 1, so 20% is 0.20. Or 0.2. So to find the complement, 1 minus 0.2 is 0.8 or 0.80, which is the same thing. If you have to express, then that's 80%. Probability of A is 65%, which means 0.65. Then complementary of that probability of A, which means probability of not A, would be 1 minus 0.65, which end up with 0.35. If you have to express in percent, that will be 35%. Okay. So these are the examples for complementary events. Okay. So what does probability of event is telling us? Probability of events is telling us that possibility that will happen, or favorably that event will happen, and always the probability of any event is always less than or equal to 1 and always bigger than or equal to 0. So when your probability value come out as like 5.7, then that's definitely wrong because it cannot exceed more than 1. Or if you get a negative value in probability, that means something went wrong, because minimum you can have is 0. Okay. So that's what probability is. Now, and the probability of single events. So to have a summary that probability of is become 1 is always happen. Probability of 0 it never happen. Probability is number of outcome favorable to events to total number of outcome. That's what probability is in ratio format. Sum of probability is always equal to 1, and that is something called complement of events. You can find out from 1 minus of the event, probability of events. Okay? So that's when we have basic definition of probability and the single event of probability. Now, chapter point 2 is some probability rules on multiple events. That means more than one event to happen next to each other, or we call compound events in here. So when you have a compound events, again, there are two basic things, compound events. Now, there are two basic things that you have to know. Since two things are happening next to each other, what we're going to do with that? Sometimes we have to multiply, and sometimes we have to add these two events. Oops. Add. But how do you know when to add, when to multiply? We usually multiply two events, like probability of A multiplied by probability of B. When you have keywords A and D. We usually add when you have keywords called OR. Then we don't multiply them. We add them. Now, when you have so we're going to talk about the multiplication rule of probability. The keywords is AND, so sometimes they call AND rules. So when do we use this? We use this when to find the probability of two or more events that happen in sequence. Okay, but in this multiplication rule, there are two kind of cases. There are two types. One is we call independent. One is we call dependent. So in independent sequence, that means each sequence are independent to each other. In other words, event A is independent to event B. So we call this, they are independent to each other, each event. So we call that case or that type as an independent sequence. So in that case, you write that probability of A and B is probability of A multiplied by probability of B, or probability of B multiplied by probability A. Okay? In other words, the order doesn't matter. In multiplication, let's say 2 times 5 or 5 times 2, both of them same as 10. So doesn't matter as long as they are multiplication. Order doesn't matter. We call this one as commutative property or commutative property. In Math 5, we learned that. So probability of A and B is always the same as probability A times probability of B, or sometimes you can get it by probability B times probability of A. Okay. So if we know two events are independent, then all you have to do is multiply each other. So for example, if event A, probability of event A happen is 0.2 and probability of event B will happen is 0.3, then what is probability of A and B will happen? So A and B, that means A and B are happening, sequentially or almost same. Then you multiply this 2, so 0.2 times 0.3 is 0.06. Many students make a mistake by answering as a 0.6, but 0.2 times 0.3 is not 0.6. 0.2 times 0.3 is 0.06. So make sure you don't make that mistake. So let's look at another example. Let's say a box container, again, three green balls and 2 red balls and 4 blue balls. A ball is randomly selected and its color is noted, and then it is placed back in the same box. Because you place it back, you always have same total number of balls, or same number of green ball and same number of red ball and same number of blue ball. So regardless of event A happen, event B is totally independent. You start from fresh, so totally independent to event A. If you don't put it back, then the event B, second event, will affected by event A because it has been not replaced into a same condition because you didn't put it back. You didn't put that ball that you just picked back into the box. So they are independent. So what would be the probability that you will select a one green ball and then you will select one blue ball? Then what you have to do is find out the probability of picking a ball which has a green color. So that would be out of 3 total green ball, out of entire number of ball is 3 plus 2 plus 4 would be 9 altogether. So it would be 3 out of 9. And since it's a independent event with the second case is choosing a ball which has a blue color, then since there are 4 blue balls, that probability will be 4 out of 9. So if you select a sequentially one green ball and one blue ball would be 3 of 9 multiplied by 4 of 9. So it will be 12 out of 81. Okay? So that will be your answer at this point. Okay, and actually you're supposed to reduce them, but we are not going to do that just purpose of just seeing what's going on. Okay, now then how about probability of selecting 2 red ball, which means first one is red and second one is also red. So probability of red would be what? 2 red ball out of 9. And the second event is another red, but because you put all the balls back, it would be 2 out of 9 again. So probability of red and red would be 2 of 9 times 2 of 9. So it would be 4 over 81. So you multiply each event to find out a independent sequential event. Then how about selecting one red ball and one blue ball? Again, probability of picking up a red ball is 2 out of 9, and probability of picking up the blue ball is 4 out of 9. So probability of red and blue, picking up the red and blue in sequence would be 2 of 9 times 4 of 9, which is 8 out of 81. So does that make sense? Okay, that's good. Now let's look at some like word problem type, more complex form of independent compound events, multiple events. Now, example 3 is saying that in Math 23 class, 20% of students were wrong on question number 1, and 30% of students get wrong on question number 2 on a test. So question number 1 and question number 2 are totally independent. So you can apply in regular multiplication rule for this multiple events to look for probability of any students who get number 1 and number 2 wrong. Okay? So probability of a event that question number 1 is wrong among the students is 0.2, because 20% means 0.20 is a 20%, but we do not write the following 0, so a lot of times we call 0.2. And probability that you will get wrong on question number 2 is 0.30. A lot of times we call 0.3. So probability of you will get wrong on both 1 and 2 would be 0.2 times 0.3, then it would be 0.06 again. So that's how do you find the probability of multiple events which they are independent. Now next examples are dependent sequence with conditional probability. Okay. They are not independent. They are dependent based on the first event, especially the second event. If the second event get affected by first event, that's conditional event or conditional probability. Then in basic rule, probability of that A and B is always probability of A multiplied by probability of B. But that's independent events. A dependent event, you write like this. Probability of A and B is probability of A times probability of B given A. Because B is the second event and that has been affected by A. So the way you said that B was affected by event A, we call B given A. Okay. And the way you write it is like probability of B, and you write a bar as given and A. So this represents that probability of B after it happened, after A event happened. So probability of that A and B in conditional events would be probability of A times probability of not B, B given A. So it's a little different. The first one is independent. Event. Second one is dependent event. The formula looks a little different. When you do the calculation, it's a number, so it doesn't look that different, but you have to be careful which number to use. That's what makes this type of question a little confusing to many of my students. So the way you write is probability of A and B is either probability of A times probability of B given A, or probability A and B, if you do event B first, probability of event B times, now instead of A, we write probability of A given B, like this. Okay. So that's the case that looking for the compound event, but it happened to be dependent, okay, compared to independent. So this is, both of them are compound event, multiple event, because you have two events happening at the same time. So if it's independent, you write probability of A times probability of B. If it's dependent with a condition, then we write probability A times probability of B given A, like that. So besides these two formula, another formula that you should recognize and remember is that what if they're asking for a conditional portion? Okay, so for example, if 2 times 5 equal 10, if you want to find out a 5, how do you find the 5 from 2 and 10? So 5 must be equal to 10 divided by 2, because you just move 2 to the other side in mathematically. So 10 divided by 2, that will be same as 5. So we are using the same concept. If probability of A and B is equal to probability of A times probability of B given A, if that's the case that we are using it, then how do you find probability of A given B? Okay, or B given A. So in this case, let's make it as a B given A first. Then again, you're moving, they're looking for this, right? So you have to move this one to the other side. So it would be probability of A and B divided by moving probability A to the other side. So it would be probability of A. So in case they ask for given portion, you find it by probability of A and B divided by probability of B. Notice that B given A, then A have to be at the denominator. Okay, then if you're looking for probability of A given B, okay, like this, probability A given B, B is the second and B is the bottom. You can relate like that way. Okay. And if they are looking for probability of B given A, then it would be probability of A and B divided by probability of A, because A event has to be happen first. Okay. Does everybody understand that? So that's a mathematical expression. So now let's look at a few more examples in here. Okay. Now basic rules here. Let's say probability A is 0.6 and probability of B is 0.5. If probability of A is equal to probability of A given B, that's another way of saying that they are independent. If they are independent, then the way you compute probability A and B is if probability A and probability B, then event A and B are independent. So probability of A and B, because of keywords A and D, you are multiplying each event. So it's 0.6 times 0.5. So you end up with 0.30. But if they give you the value of given value, like if probability of B given A is 0.4, the probability A and B, because if B is not equal to B given A, B is 0.5 and B given A is 4, so if they are not equal, then probability of B, they are independent, they are dependent events. So if they are dependent events, to find probability of A and B, you multiply probability of A times probability of B given A, because A was given first. Then you have to use B given A for the second event, or vice versa. Because you are using B given A, or B given A is known, the first event has to be probability of A. Then you multiply 0.6 times 0.4, which is 0.24. So that's another case. Now, if you, how about probability, if probability of B given B is 0.30 this time, not A given B is 0.30 rather, not B given A, then how do you find a probability of A and B? Again, if given value is known as a 0.3, then probability A is not same as probability A given B, then they are also dependent. So how do you find probability of A and B? Because they gave you probability of A and B, you are using this, then first at the second event, and first event has to be probability of B, because B is on the second. B is in the first event. So you don't choose probability A here, you choose probability B here because of this B. Then 0.5 times 0.3, 0.15. Okay. Now you will have a more example like this, so let's look at another examples. Number 4, if probability A and B is 0.06, find probability of A given B. So probability A given B is always probability of A and B divided by probability of B, because B is the first event. So 0.06, because that's what they gave to you, divided by probability B is 0.5, so you get 0.12. What if they want to compute probability of B given A? So probability of B given A is probability of A and B divided by probability of A, because that has to match with first event. So 0.06 divided by 0.6 is 0.10. So everybody understand this? So now let's look at another set of problem, but similar one that we had. Okay. Now try to find set 2 when probability A equal 0.5 and probability of B is 0.4. Number 1, if probability of A given B is 0, compute probability A and B. Actually, this is, instead of 0, I should have said probability of A given B is the same as probability of A. Okay, so in that way, this implies they are independent. Okay. So if I erase this, probability of A, that imply they are independent. Then find probability of A and B. But if number 2, if probability of B of A is 0.3, find the probability of A and B. Number 3, if probability of A given B is 0.2, compute probability of A and B. And number 4. So try these questions. See if you can handle this. So pause the video and you can try on your own. Okay. Now the solution comes on next page. Probability number 1, probability of A and B, since they are independent, you multiply each other's and then become 0.20. Now when probability of B given A is given as a 0.3, then you have to use that 0.3, and A have to match it. So 0.5 times 0.3 equal 0.15. How about number 3? Instead of B given A given B is given in this case as a 0.2. Probability of A and B is, now you have to use A given B, because that's the value they gave you as a 0.2. Now you use probability of B, so find that value, and it would be 0.08. Does that make sense? So many things to think about, but that's how you do it. Now, 4, question number 4. If probability of A and B is given as 0.05, then find the probability of A given B and find the probability of B given A. Again, probability of A given B is probability of A and B divided by probability of B. So it's 0.05 multiplied by divided by 0.4, which is 0.125. And likewise, probability of B given A is probability of A and B divided by, this time, probability of A, because that has to be matched, like B and here B matches. So that will give you 0.05 divided by 0.5 is 0.10. Okay. Now, that's in terms of mathematical expressions. Now let's look at some word problem, see if it makes sense. In a Math 23 class, Professor Kim taught there were 6 A's in 2014 and 8 A's in 2015 and 6 A's in 2016 again. If Professor Kim wishes to select at random 2 A students from 2S to tutor other Math 23 students, what is the probability that both tutor will be from A's of 2015, year 2015? So how do you solve this question? Number one, is anything with a probability, you have to find the total. So total number is adding 6 plus 8 plus 6, which is 20. So since you have a 2, you have to choose 2 to the first one is, let's say, probability of A students 1. And second event would be finding a probability of student who got A in 2. So let's assume that it's A1 and A2. So probability of A1 is first A in 2015 would be, since there are A people who got A in 2015, it's 8 out of 20. Now to choose the second students, total number has been affected. There are not 20 anymore because one has been chosen, so you cannot use that first tutor that you chosen as the second tutor. So instead of 20 people, now you have a pool of what, 19. So 19 students is in total, so it has been affected. Okay. And also there were 8 number of students got A in 2015, but since one is chosen, now the pool has only 7 from that 2015 who got A's. So probability of second A in 2015 given to first A in 2015 is 7 out of 19. So it's not 8 out of 20 anymore. One has been chosen already, so it has affected as a 7 out of 19. So probability of choosing 2 students is from 2015 is probability of A1 times probability of A2 given A1. So it's 8 out of 20 multiplied by 7 out of 19, which is 56 out of 380. Does that make sense? Well, that's good. Yeah. Because the first event affects the second event. So number shouldn't be exactly the same, or probability shouldn't be same anymore. Total number has been affected. Number of students you have left has been affected. Now let's look at another type of question. During 2016 academic year, average of 60% of the students at every student study world high school caught on common cold. So probability of common cold would be 0.6 or 0.60. And then 40% of a student caught a flu. So probability of flu would be 0.40 or 0.4. Okay. Now they have another information. They said among the students who caught a common cold, 30% got flu. So who got flu? 30%. But that's 30% is only who had common cold and then got a flu. So it would be flu but after you got a common cold. So that's what they are saying it. So among the students who got cold, so cold is always the first event, and also get flu, that's 30%. That's what they are saying. So be able to rationalize this is very important, because that is like a probability of a flu given or a flu after common cold is 0.30. So having this said, now final question is, what is the probability of randomly selected students has common cold and flu? So they are looking for probability of common cold and flu. Okay. So now you can use the formula that since flu given probability of a flu given cold is there already at a 0.3, as a second event, the first event should be what? First event should match with this, right? So first event would be probability of common cold. So how much was the common cold? Common cold was 0.6, and you multiply them with how much was the probability of flu given cold? That was 0.3. So 0.6 times 0.3 would be 0.18. Okay, so that's how you got that. So depending on what is given to you, you have to be carefully use that number. Okay, does this make sense? Okay. Another example. During the 2016 academic year, average of 60% of the students in every student does well in high school caught a common cold. So 6% in this case, probability of common cold is 60%. And 40% got a flu. So probability of a flu is 40%. So this looks like the same as previous one. Okay, that's good. Now, but here is different part. Among the students who got caught the flu first, 30% caught common cold second. Okay, so they didn't say first and second, but that's they imply. So this is a conditional dependent one. So you use probability of which one first? Flu first, right? Flu given common cold. No, this is, they are looking for flu first, and their 30% is common cold. So you have to write a common cold first, because that's what 30% is. So here and there, because 30% represent a common cold among the people who got flu. So first step was flu. That is 0.30. Okay. So now, knowing this, how do you find the probability of common cold and flu. So again, common cold and flu is flu times, okay, common cold and flu. Because common cold and flu is given as 30%, we have to use this. Then you need the flu this time. So 0.4 times 0.3 is 0.12. So this question is very similar to the previous question, but the conditional part is different. The previous one was among the students who got common cold, 30% got flu. Okay, but the second one is saying among the students who got flu, 30% got common cold this time. So depending on the way they're saying it, it's different. So you have to be careful about that. Okay. Now another example. Probability of Brian being hit by yellow and red and black paintball is 0.6, 0.7, and 0.5. So yellow is 0.6 and red is 0.7 and black is 0.5 respectively at a paintball game. Now they want to compute probability that he got hit yellow and black. Okay, so you have to find out yellow first, which is given as a 0.6, and red is 0.7, and black is 0.6. So yellow and black, they are independent, is yellow times black. So 0.6 times 0.5, which is 0.30. So this is a typical independent because getting yellow or getting hit by black is totally independent in this particular case. Now let's look at the second cases. The probability of Brian get hit by black ball after getting hit by red ball is 0.4. Okay, so that means black ball hit by black ball given red ball is 0.4. That's what they're saying. So since that sequence is formed and given to 0.4, they have to be a dependent event. Then probability of red one and black in particular sequence of red after black given red is 0.7 times 0.4, which is 0.27. Okay, does that make sense? Because he could get hit by all different way, but in this particular sequence only, then that's how you get that. How about probability of Brian get hit by yellow ball after getting hit by black ball? So yellow given black is 0.3. So that has been set up, then they are independent events. Then paint with the yellow and black is paint black times yellow given b, because yellow given b is the value they gave you first. So because of the black is the second one, you have to, black is the first event, so you have to get a first event black first. So 0.5 times 0.3 is 0.15. Okay. Now similar one to that, number 4, how about the yellow ball and black ball in any sequence is 0.06. Then A, what is probability hit by yellow given black? So yellow given black is yellow and black divided by black, because that had to match with this. So 0.06 divided by 0.5 is 0.12. If they are looking for probability of black after given yellow ball hit by first, then it will be probability of yellow and black divided by probability of yellow. Okay, this yellow and that one. So 0.06 divided by 0.6 is 0.1. Another example is, let's say that Stacy has a test anxiety, and probability that Stacy passed the science, no, not that one, that's number 2, sorry about that. Number 1, probability of Stacy passed the math final is 0.6, English final is 0.7, and science final is 0.5. Compute, if they are independent event, usually they are. Math is nothing to do with the science. So what would be states pass the math and science final? So in that sequence would be 0.6 times 0.5 would be 0.30. Okay. But that's the case when they are independent. Now, if they are not independent in whatever the reason, then followings are dependent or conditional clauses. Example, Stacy has a test anxiety. The probability that Stacy passes the science final after passing a math final is 0.4. Okay, so compute, I guess, either whichever final he liked first give you better confidence because you like the subject, so you probably did better. But in the same day it's 0.4, but computer probability of Stacy pass math final and science final in the same day. So these we make it as independent events because they want to have, you want to make it a dependent events. So since math final first and science final second is given, P of science after the math is 0.4, then we need P of math to find the probability of math and science. So you multiply 0.6 times 0.4 is 0.24. Now probability of states of math final after science final. So that's what given is probability of math given after the science is 0.3. So that's 0.3, and you have to use science because this is S. Multiply together, 0.01. How about probability A students? Let's not talk about states anymore. So now students take a math and science is 0.6. So this is 0.6. And compute that probability that takes a math final from who is taking science final. So that means find the probability of like A given B format. So probability of math given science, that's what they're looking for, right? So math given science, it would be math and science divided by science. So you got 0.12. Notice that this science and that science has to match. The second one is they want to find out the science first after they want to find out science after they taking a math. So they are looking for probability of science after they gave you math. So that's what they're looking for. Then it will be math and science divided by math. They have to match with this. So you got 0.10. So it looks confusing, looks hard, but you really have to read carefully and see what is given, and you have to find out what you need to get the answer. Okay? Now let's look at some other type of questions. We call table type. Table type of question. Now local factory employee has following licenses. Company type C license, there are 110 male and 20 female, total 130. Another license, D license, there are 30 people has that, and 50 people has, 50 female has D license, and total is 80. So when you add this 110 plus 20, you got 130. And when you add the 30 with the 50, you got 80. But in terms of total male would be 110 plus 30, 140. Total females is 20 plus 50, which is 70. Okay, so from here, one person is selected at random. Compute the following probability. What is the probability? You choose one person. What is probability that person has a C drive license? So the way you get a probability is total of C divided by entire amount. So 130 out of 120, because there are 130 people who has a total license, C license, and there are 210 people are there altogether. Okay, so this is a single events, I guess. So those are the single events. One person happened to be who has a driver license. D is total number of D out of total entire final is 80 out of 110, because D is 80. Now, what is the person you choose who happen to be a male is probability of that is total male out of entire people. So 140 out of 210. The one person select happen to be a female would be older female out of entire total. So 70 out of 210. What if you want to find a probability one person happen to have not only who has a C drive license, but also is a male. So it's like compound events. But in table format, it goes like this. It's a C and male. So you have to look for C and male out of the total. So where is the C and male? C and male is 110. So that's why it's 110 out of 210. So let me erase some of this. Now, the second one is that what if find out that who has a drive license, D and female, then D with female would be 50. That's the common. So D with a female, 50 out of 210. Next one is a C, number 7 is C and female. So C with a female would be 20. So probability of that is 20 out of 210. Okay. How about D, one who has D drive license and male? So D with a male happen to be 30. So it's a 30 out of 210. So those are the more like you have to have two conditions, not just one. Okay, from the table. Now another type of question is find a person that what is the probability the person you picked was C given male. So C given male is always probability of male and license C divided by probability of male because of the given. So probability of a male and C is this, right? So that out of probability of male, which is this, right? So that becomes 30 out of 210 divided by 140 out of 210. The simple way of doing that is 210 and 210 cancel out. You end up with 30 out of 140. Okay, so you got 30 out of 140 because two denominator cancel out. Then how about number 10? Probability of D given male is probability of male and D license divided by probability of male. Oh, that's what it was? Okay. So that was, I was wrong before. Number 9 was 110 out of 210 divided by 140 out of 210. So 210 and 210 cancel out. You end up with 110 out of 140. That was number 9. Number 8, sorry. Number 9. Okay. So that was number 9. And number 10 is 30 out of 110, which is 140, sorry. So that was that. Now, number 11, probability of a C given male is probability of a female and license C out of female. So female license C is this. Female license C. So 20 out of 210 divided by female. Female was 70 out of 210. So 210 and 210 cancel out. You will probably end up with 20 out of 70 as a final answer. Okay. And probability of driver D given female would be 50. Female out of who has a D drive is 50 out of 210. So that's 50 out of 210. And female is 70 out of 210. So 50 out of 210. So 210 and 210 cancel out. You end up with 50 out of 70. Okay. So only practice make perfect. You have to think hard and do these problems. Okay. So that's when you have multiplication, multiplying, or in this case, sometimes it's dividing cases. So that's what we're going to go so far. So please review this many times and see how it goes, and then do some exercise in the back. Okay. So that will be it for today. I will talk to you. I will see you in next videos. Okay.